rationals. When we add and subtract rationals, we're following the same rules as fractions, so we have to have common denominators. So example 1a has 2x over 3 minus x over 3. 2x minus 3 over x over 3. They both have the common denominator of 3, so you write the denominator once. And then you actually do the operations to the top. So you're going to go 2x minus x. You can only put them together like this if you actually have a common denominator, which we do. Now, 2x minus x is like 2 apples minus 1 apple. So on the top, we're going to end up with 2x minus 1x, which is x over 3. And we have to remember at the very end to state non-permissible values if there are any. But right now, our denominator doesn't have a variable. So we would just have, for NPVs, we would have 3 cannot equal 0, which is true, but not a non-permissible value. So we don't have any non-permissible values. So that's 1a, which is a nice one because it already has a common denominator. The first examples in 1 all have common denominators because we're going to learn how to actually do the operations on the top first before having to find common denominators. So that's 1a. 1b is 2a minus 3 over 5 plus 9a plus 1 over 5. So they're both over the denominator of 5. So that's our very first step. We have to get a common denominator. If we don't have one, we have to make a common denominator, but we already have one, so we're good. So we can just write the numerators, the tops, all over one denominator. Because they're both over 5, the whole thing's going to be over 5. And then we just rewrite our numerators. So we have 2a minus 3 plus, we're going to add to it 9a plus 1. Okay, so once we have a common denominator, we can just write all of our numerators, our tops, over our denominators, our bottoms. Then we can collect like terms. So we have 2a plus 9a, just like 2 apples plus 9 apples. So we have 11a. And then we have negative 3 plus 1, which is minus 2 over 5. And then once again, our denominator doesn't actually have a variable or a letter in it, so we have no NPVs. Because we only get non-permissible values or restrictions. We have a variable in the denominator. So that's 1b. 1c. Tell me if I need to slow down, if I'm going too fast. 1c, I have 3x over 4 plus x over 4. So when I go to add and subtract, multiplying, dividing, and simplifying, you don't need common denominators. But adding and subtracting, which is our last lesson, you need to have a common denominator. So we both have denominators of 4 and 4, so we can write them all over 4. And then we can rewrite our numerators, 3x plus x. And then we can collect like terms. So we get 3x plus 1x is actually 4x over 4. Well, we have it over 4, so we have no NPVs. And everyone wants to stop there. But remember, I told you when you have two things multiplied together with not a plus or minus sign, they can go in separate brackets like this. So technically, there's a 4 in the top in brackets and a 4 in the bottom in brackets, so they can actually cancel each other off. But you always have to state non-permissible values before you cancel. So in this case, I have stated there aren't any, and then I can cross off. So we always have to state non-permissible values before we cancel. So we get equals x. So when I take this 3x plus 4 and I add it to x plus 4 and I simplify it, the answer is x. Okay, then I have 1D. This one's where it gets a little harder because we're subtracting, but we still have common denominators. So I have 5y minus 1 over 6 minus 4y plus 7 over 6. So they're both over 6, which is a common denominator of 6. So I can go right to my next step, because the first step I need is common denominators, and I already have them. So then I'm going to put it all over 6. Now this is the catch. I'm going to go 5y minus 1. And then I have to minus, and this is when you minus more than one term. So if you're subtracting more than one term in the numerator, you guys, you have to apply that minus sign to everything behind it, because you're subtracting everything behind it. So this is a binomial. So this is where all the errors are going to happen. So when I have a subtracting a binomial, I have to subtract 4y, and I have to subtract 7, positive 7. So I have to make sure, because people will just apply the minus to the 4y, but you're actually subtracting 4y and 7. So we're going to get minus 4y minus 7, because you have to subtract the 4y and the positive 7. Okay, so that's where the error happens. That's the only extra step, because we have the subtraction there, and now we can collect like terms like we did before. So we have 5y minus 4y is y. And then we have minus 1 minus 7, which is minus 8 over 6. And then I have to state NPVs. There aren't any, no NPVs, because I have a 6 in the denominator. And remember, 6 can never be 0, and the only place we get NPVs is if we actually have a variable equal to 0. And this is y minus 8. It's in its brackets together, because when they're attached by a minus sign, you cannot separate them. So even though the 8 and the 6 you think you could maybe take something out of, you can't, because the only way this y minus 8 is going anywhere is if there's a y minus 8 on the bottom. So we're actually done. That's number 1. Example 1. Now example 2 gets a little harder because we don't have common denominators. But it's still easy denominators to make, like we would have in junior high, because they're all numbers on the bottom, no variables. So example 2, A, we have 3x over 4 minus x over 3. So now we have a 4 in the denominator and a 3 in the denominator. I swear these are written straight, but in order to fix the glare, I have to lean my computer down, and so it looks like I'm writing at an angle, but I promise it's actually straight on. I also look like I'm going downhill. Okay, so we have a 4 in the denominator and a 3 in the denominator. The only way you can make common denominators is by multiplying. So we have to say, what can I multiply 4 and 3 by to make them both be the same? So what's common to 4 and 3? Well, what's common to 4 and 3 is 12. So I can make 4 be 12 by multiplying by 3. I can make 3 be 12 by multiplying by 4. The catch in making common denominators is you have to multiply the top and the bottom by that number. So on this side, I'm going to multiply the top by 3 and the bottom by 3. So I get a 12 on this side. And on the right-hand side, I'm going to multiply the bottom by 4 and the top by 4. We have to do it to the bottom and the top, because when you multiply by 4 on the top and the bottom, you're just making it equivalent. You're not changing it. Okay? So what we're going to do is we have to make common denominators first. On all the examples before, we had common denominators ready. So now we have this equals 3x times 3 is 9x. 4 times 3 is 12. So now we have 9x over 12 minus sign. X times 4 is 4x. 3 times 4 is 12. So I have a common denominator of 12 now, and I'm just at the exact same step as I was in example 1. So there's one extra step here. I have to make them be common. But once I make them be common, I'm back to example 1 again. So now I have common denominators. I can write them all over one denominator of 12. And then I have 9x minus 4x. And then I can collect like terms. 9x minus 4x is actually 5x. So I'm going to get 5x over 12. And I have no NPVs because this 12 is, it's not a problem, right? So I have no NPVs because there's no variables in the denominator. Now I have to see, can I simplify? Well, I have a 5 times an x and a 12 in the bottom. Can I take anything out of 5 and 12? No, there's nothing common to 5 and 12, so I'm done. And if you just wrote 5x divided by 12 without brackets, that's totally, completely correct. There's nothing wrong with that. Okay? Let's look at B. So B is 3a minus 1 over 3 plus 4a plus 5 over 6. So our first step is common denominators. We can't get a common denominator here. So we are going to have to figure out what can I make 3 and 6 be. And remember, you can make common denominators by multiplication. And you don't always have to multiply both. And in this case, you wouldn't have to, because the lowest common denominator, I can make them both be a 6. And 6 is already a 6, so I don't have to multiply anything on this side. So I could multiply the top and the bottom by 1. I could do that on the 6, but I don't have to. So I'm going to multiply this one by 2 and this one by 2. Now the catch is, on the last one I was multiplying monomials. There's only one term in the top. This one there's 2, so I have to make sure I multiply both of those top terms by the 2. So I'm going to get 2 times 3a, which is 6a, minus 2 times 1, which is 2, all over 6. And then this one stayed the same because I didn't have to do anything to make it a common denominator. So now I'm back to the same steps as in example 1. I have a common denominator of 6. So I'm going to have 6a minus 2 plus 4a plus 5. And I don't have to worry about anything with this 4a plus 5 because I'm adding it. It's only when you subtract that it makes it complicated, where you have to distribute that minus sign through. So now I can collect like terms and put it all over 6. So I'm going to get 6a plus 4a, which is 10a. And then minus 2 plus 5 is plus 3. Can I take anything out of 10a plus 3, a GCF of any sort? Nope, so it stays 10a plus 3 and the 6. And remember, the 10a plus 3 is in brackets together because they're attached by this plus sign. So I can't take this 3 and cancel it off with the 6, because the 10a plus 3 is only going somewhere if there's a 10a plus 3 in the denominator, and there's not. So this is as good as it gets. And I have a 6 in the denominator, not a variable, so I have no NPVs. I have one more example, C. For example 2. So if you have any questions or I make a mistake, please comment. Okay. So C is 8y minus 3 over 8 minus 2y plus 1 over 3. So the first step I need to do is I need to make a common denominator. And what's common to 8 and 3? What can I multiply them both by to get the same number? Well, 8 and 3, you can make both of them be 24. Because 8 times 3 is 24. So your lowest common denominator between the two is actually 24 when you multiply them. So I'm going to have to multiply the left side by 3, the whole left side by 3, and the whole right side by 8. So there's lots of distributing. So I'm going to get 8y times 3, which is 24y, negative 3 times 3, which is minus 9, over 24, minus 2y times 8, which is 16y. Do you see how I don't even deal with the minus sign? I just leave it here in between. Don't even touch it. So 2y times 8 is 16y, plus 1 times 8, which is 8, over 24. And now we're back to the same, very similar example as the last one in example 1, because we have a minus sign with 2 terms after, common denominator now. So I'm going to put it all over 24. I'm going to go 24y minus 9. And then I have to remember when I have a minus sign and more than one term behind, that I distribute that minus sign through. And that's going to be where you're going to common error, is not distributing that minus sign. So we're going to go minus 16y. And then minus 1 times 8. So that's minus 8. And now we can collect like terms. So we're going to go, I don't know, I keep closing this with blue marker. 24y minus 16y is 8y. Minus 9 minus 8 is minus 17. And these are attached by minus signs, so they'd be in brackets together, over 24. 8y minus 17, I can't take anything out to the front of it, so it's just 8y minus 17. It's not going anywhere because I don't have an 8y minus 17 in the denominator. So that's as good as it's going to get. That's going to be my answer. And I have to say no NPVs because I don't have any variables in the denominator. So this lesson is going to be a little bit longer because I'm doing it as one lesson instead of two. Okay, example 3. We're kind of going back to me giving you common denominators, but our common denominators now have variables. Okay, and then example 4, we're going to have variables without common denominators. All right. Example 3a. We have 2 over x plus 7 over x minus 1 over x. So here we have 3 rationals added and subtracted together. Our first step when we add and subtract rationals is we need to have a common denominator, and we already do. So since we have a common denominator, we can write them all over x. And then we just rewrite our numerator on top. So we get 2 plus 7 minus 1. Collect like terms. 2 plus 7 is 9. Minus 1 is 8. So I get 8 over x. Now I have an x in the denominator, so I have to state non-permissible values. So I take that denominator, which is just an x, and I'm going to go x cannot equal 0. And then I'm actually done because I don't have to do anything. It's ready in x equals form. So my answer is 8 over x. Could you put brackets around the 8 and brackets around the x? Absolutely. It doesn't matter. Or you can have no brackets. Totally fine. And then we have a semicolon. X cannot equal 0. And that's your answer. So that's for example 3a. Example 3b. We're going to have 5a plus 3 over 2a plus a minus 6 over 2a. So my very first step, I have to have a common denominator, which I already do. Okay, so I already have a common denominator of 2a. So I'm going to rewrite it all over 2a. And I told you, if you have a 2 and an a multiplied, I would put them in their own brackets because it makes NPVs easier and simplifying easier. Because they're not attached by plus or minus sign, so they can go in their own brackets. And I can rewrite the top, 5a plus 3 plus a minus 6. When I add, it doesn't change my signs. So now I can rewrite my denominator. I have a 2 and an a, and then I collect like terms in the top. So I get 5a plus a, which is 4a, or 6a, not 4a. And then 3 minus 6 is negative 3. And we've been done at this point the whole time. But our very last step, we have to check and see, can we take a GCF out of the numerator? Once we've collected like terms, that's our last step. See if we can take a GCF out of the numerator. We can take out a 3. Out of 6a minus 3, we can take out a 3, so we write the 3 in front. 6a divided by 3 is 2a. Negative 3 divided by 3 is negative 1. And then on the bottom, I have 2 and a. So on the top, I have 2a minus 1, no 2a minus 1 on the bottom, so they're not going anywhere. The 3 and 2, I can't take anything out, and the a, I can't take anything out. Now, the key thing to this as well is that even if you could cancel something off, you have to state non-permissible values first. So our NPVs are going to be 2 can't equal 0, which is true, but not an NPV. So we have 2 can't equal 0. And then we'd have a can't equal 0, which is true, and we're done. We're going to follow behind with semicolon, a cannot equal 0, and then box it. Then for C and D, we have subtractions, but common denominator still, so that's good. So for C, we have 3y over 3y minus 1 minus 1 over 3y minus 1. So we have common denominators again. So that's good. We just have to write them all over one denominator. So it's going to equal 3y minus 1 in the denominator. And then on the top, we can now write them together. So we're going to go 3y minus 1. Oh my goodness, they completely match. I'm going to get excited and want to cancel them off, but I can't cancel them off until I state non-permissible values. So my NPVs are going to be 3y minus 1 cannot equal 0. So I have to add 1 to both sides. 3y cannot equal 1. And then I have to divide by 3. And I get y cannot equal 1/3. That's my only NPV because that's my only thing in my denominator. And then 3y minus 1, 3y minus 1, they cancel. And whenever they cancel, these little slashes are actually 1s. If you didn't know that. Every time you cancel, you actually are left with a 1. So 1 divided by 1 is 1. So this simplifies to 1. Oops, I just messed up. 1, but I have to say, semicolon, y cannot equal 1/3. Because I need to state my NPVs before I cancel. So yes, it went away here and I just got a 1, but because it was here at some point, I have to state the non-permissible value for it. I can't just ignore it. So I always have to state NPVs before I cancel. That's a huge, important step. Okay? Just drop my marker. Okay. Ah! So weird. Like, just like, you know, walking down the steps. Okay. D. All right. With D, we have 4y plus 10 over x plus 3 minus 2x plus 4 over x plus 3. So we have common denominators. That's our first step, so we're good. Oh my gosh, I keep dropping the lid. I've been in isolation too long. I don't even know how to act in front of a board. Okay, so we get x plus 3 in the denominator, and then we're going to get 4x plus 10. And then I have to remember I have a minus and I have more than one term behind it. So I have to minus the 2x and I have to minus a positive 4. So when I minus 2x, I get minus 2x. When I minus a positive 4, I get minus 4. And so then, now I can collect like terms. So I'm going to get 4x minus 2x is 2x. And then I'm going to get plus 10 minus 4 is plus 6. Now remember, after we get collect like terms, we also have to check and see if we can take out a GCF out of the numerator. That's our next step. So we also have to make sure we can see if we can take a GCF out. We can take out a 2, and then we're left with x. 2x divided by 2 is x. 6 divided by 2 is plus 3. And then on the bottom, we have an x plus 3. So we can see that they cancel, but we cannot cancel them until we stated non-permissible values. So we have x plus 3 cannot equal 0. Subtract 3. X cannot equal negative 3. Now, once we stated our NPVs, these can cross off, and our answer is 2. With a semicolon behind it, x cannot equal negative 3. Okay, then we have example 4. We have 2 more examples left. Example 4 is where we don't have common denominators, but we do have variables, but they're all monomials, so we're going to make them the same. And example 5 is where we don't have common denominators, but they're not monomials. We have to make them the same. Monomial means one term, no plus or minus signs in your denominator. Okay, so we're going to look at example 4, and then we just have example 5 left, and then we're done. And that's your week's lesson, and then you've learned all of your 30-2, and you just have a review next week, which replaces an online assignment. Okay, so no more lessons after this one, no more new ones. So example 4, A, we have 5 over 3p plus 2 over 7p. Now, the 3p and the 7p don't have plus or minus signs, so I'm going to put them in their own brackets. Okay, now I need to make a common denominator. Both of these actually have p. This one has a p, this one has a p. So I don't have to do anything to that variable because the variable is common between the two of them. However, the 3 and the 7 are not the same, so I have to make them common. So if I times the right-hand side, this one you have monomials. If they're not the same, you can look at your brackets. So I'm going to times this one by 7, and then I'll get 21p on the left. And I'm going to multiply the right side by 3, and then I'm going to get 21p on the right. Okay, so 5 times 7 is 35. 3 times p times 7 is 21p. And I'm going to put the 21 and the p in their own brackets because it's multiplied. And then plus 2 times 3 is 6 over 7 times p times 3, which is 21p. So I have a common denominator now. So when they're monomials, you have to make their variables the same and their numbers the same. The variables happen to be the same in both of these. So I have a common denominator, so I can write them over that denominator. I'm going to get 21p in the denominator. And then I get 35 plus 6. Write my numerators together. When I collect like terms, 35 plus 6 is 41 over 21p. Now there's nothing I can take out of 41 and 21. There's nothing in common between them. 41 is a prime number. But I have to state NPVs. So my NPVs are going to be 21 cannot equal 0, which is true, but not an NPV because NPVs come from variables. And then p cannot equal 0. So that's my only NPV. So I have to follow behind this with a semicolon. P cannot equal 0. So that's 4A. 4B is a monomial denominator again. So the denominator, it doesn't have plus or minus signs. So we're going to go over 4b. 4b has 1 over 3y plus 6 over 5. Now the 3 and the y are separate. I'm just going to rewrite it so I can put in brackets apart. So I have a 3 and a y in brackets, and this one I have a 5. Okay? There's no plus or minus signs. This is a monomial. So if you have monomials and they're not the same, you're going to follow example 4. So I lumped them into certain examples. So when you get to your assignment, you can look and say, okay, this question is an example like example 4 because the denominators aren't the same and my denominators don't have plus or minus signs. So I can use example 4 to look how to do this. Okay, so each example has specific different things. This one's a monomial in the denominator that don't match, and one of them has a variable at least. Okay, so I have a y on this side. I do not have a y on this side, on the right. So I know I'm going to have to very well multiply by y. Okay, so now I have 3y and 5y. So I'm getting closer. But the 3 and the 5 aren't the same, but I can make them be 15. So I have to multiply the right by 5. That's a left. Left by 5, and the right by 3. So on the left here, I have 1 times 5, which is 5. And in the denominator, I have 3 times y times 5, which is 15y. And then plus 6 times y times 3 is 18y over 15y. Now, you're going to have to stop yourselves because in the next step, you're going to try and simplify these off. Don't simplify them off. You just made them have common denominators. So your first step is to get a common denominator, and your second step is to write them over that common denominator. So the next step, you shouldn't even think twice. You have a common denominator now. You just write it over that common denominator. Okay, so I get 15 and y. And so I'm going to get 5 plus 18y in the top. 5 plus 18y, once you've collected like terms, which we have, there's nothing else I can collect. I have to see if I can take a GCF out of the numerator. So 5 plus 18y, is there anything I can take out of that that's common? No, I can't. So that is in brackets. So unless there's a 5 plus 18y in the denominator, it's not going anywhere. And there is no 5 plus 18y in the denominator, so it's staying. And then I have to state my NPVs. My NPVs are going to be 15 cannot equal 0, which is not an NPV. And then y cannot equal 0. So I just have to follow behind this with y cannot equal 0. And then I'm done. Because 5 plus 18y, I can't simplify at all. Okay, and we have C. C is 2x minus 5 over 6x minus 3x minus 2 over 3x. So let's look at that one. So when you go to do your assignment, try and figure out which example it's like, and then you can follow those examples. So that should be your very first step. Okay, so C, we have 2x minus 5, make a new marker, over 6x. The 6 and the x be in their own brackets because it's monomial, minus 3x minus 2 over 3x. Okay, so the first step is we have to make a common denominator. Both of these have an x, so that's good. This one has a 6, and this one has a 3, so I can make the 3 be a 6 by multiplying by 2, the whole top. So I'm going to rewrite it. I get 2x minus 5 over 6x minus, I have to distribute that. Minus sign just stays here, I don't deal with it. 3x times 2 is 6x. Minus 2 times minus 2 is minus 4 over 6x. Now I have common denominators. So I'm going to get it all over 6x. Then I'm going to get 2x minus 5. And then when I subtract, I have to remember to subtract everything behind the subtraction. So I minus negative 1 times 6 is negative 6. So I minus a 6x, so I get negative 6. And I minus a minus 4. When I minus a minus, I actually get plus. And then I'm going to collect like terms. So I'm going to get 2x minus 6x is negative 4x. And then I get minus 5 plus 4 is negative 1. And that's in brackets because they're attached by minus sign over 6x. And then I told you the last step is to always, after you've collected like terms, to check and see, can I take anything out of this numerator, GCF? I have negative 4x minus 1. I could take a negative 1 out. But if it's just a negative 1, you don't have to. Then you have a 6 and an x. Substitute my NPVs. And I have 6 cannot equal 0, which is not an NPV, and x cannot equal 0. So behind this, I have x cannot equal 0. That's my answer. I'm going to erase just the top here because I want you to try D on your own. So D is a plus 7 over 2a squared, and I would put the 2 and the a squared in their own brackets, minus 3 over 5a. They're in their own brackets. So you try that one out on your own. I'll give you a couple minutes here. Try that one out. Make a common denominator. Okay. So we're going to try this one. I got some more board markers and hopefully they work better. Okay. So what's common to a squared and a? They're very close, but this one I'm going to need to multiply by an a. Oops, got a new board marker and then didn't open it. Multiply by an a. Ooh, look at that. Because a times a is a squared, so then our a's will be the same. And then we have a 2 and a 5. So I'm going to multiply this one by 5 to make it be 10. And I'm going to multiply this side by 2 to make it be 10. So when I distribute the top, I'm going to get a times 5, which is 5a, Wow, that's way better, that marker. And then 7 times 5, which is 35, over 2 times 5, which is 10, a squared, minus 3 times 2 times a. These all get multiplied together because there's no plus sign in there. So 3 times a times 2 is 6a, over 5 times a times 8 times 2 is 10a squared. So now I have a common denominator. So I get a 10 and an a squared in the denominator. In the top, I get 5a plus 35 minus 6a. And so I'm going to get, collect like terms, so 5a minus 6a is negative a, or negative 1a if you like, and then plus 35. I put that in brackets because they're attached by a plus sign, over 10a squared. Now there's no more simplifying I can do because negative a plus 35 is on the top and there's no negative a plus 35 at the bottom, so it's never going to go away. So I do have to state NPVs. 10 cannot equal 0, which doesn't give me an NPV, and a squared cannot equal 0. Square root a cannot equal 0. Let's have to put that behind here. A cannot equal 0. Okay, we have one more example left. Oh, it's continuation of example 4. My bad, I thought it was example 5. So this one, we have a monomial on one denominator and a binomial on the other denominator. So E, we have x minus 9 over 2x, which is a monomial, 2 and x, and then plus 3x over x minus 4. So the moment you have a binomial in the denominator, for the ones that we're going to do, the moment you have a binomial in the denominator, the fastest way to make a common denominator, and I guess the only way to make a common denominator for the ones that we're doing, is we multiply each of them by each other. So I'm going to multiply this side, the 2x, by x minus 4. So the top and the bottom. And then the 3x minus 4, I'm going to multiply by the other denominator, 2x. So when one of them is a binomial, so here I had an x minus 4 in the denominator, immediately when I get a binomial, I just multiply each denominator by each other. Okay? So the moment I have a binomial, which are the harder ones, I'm going to multiply each denominator by each other. Now, the top here has 2 terms times 2 terms, so we have to FOIL, like we learned in grade 10. So we go x times x, so that's x squared. So first, then outer, x times negative 4 is negative 4x. Then inner, negative 9 times x is negative 9x. Then last, negative 9 times negative 4 is positive 36. All over, then you just write the 2 denominators. You never distribute the denominators when it's one of them is a binomial. Okay, you just write them side by side. So I'm going to go 2x, 2 times x, and x minus 4. Okay, then plus, now here I have 3x times 2x. These don't have any plus or minus signs in between, so we don't FOIL them. We FOILed these because I have x minus 9 and x minus 4. These we just distribute because it's 3x times 2x, which is 6x squared, all over 2 times x minus 4. Okay, so when we have a binomial, we multiply them by each other, and we're just going to rewrite the denominator and not put them together. Okay, so now we have to write all over one denominator because we have a common denominator. 2x, x minus 4, and then we get x squared plus 6x squared is 7x squared. Negative 4x minus 9x is negative 13x. And then plus 36. And those are all attached with plus or minus signs. So they go like this. I'm not going to make you factor them. So that's as good as it gets. But we can't quit until we state our NPVs. So our NPVs are going to be 2 cannot equal 0, which is true, but not an NPV. X cannot equal 0, which is done. And then x minus 4 cannot equal 0. So we add 4. X cannot equal 4. And then we state our NPVs with a semicolon behind. So we say x cannot equal 0 or 4. And that's my answer. 2 examples left, and then you're done the last lesson of grade 12 math. 2 examples left. All right, F. F is 4 over 2y plus 5 minus 1 over y minus 3. I have denominators that are binomials, right? The moment I immediately have a denominator that's a binomial, you guys, what I tell you have to do to make them common, multiply them by each other. Actually, when you have denominators that are binomials, it's really easy to figure out what your common denominator is, just the 2 of them multiplied. So this one's 2y plus 5, this one's y minus 3. So I'm going to multiply this one by y minus 3, top and the bottom, and this one by 2y plus 5, top and bottom. So this equals, I distribute 4 times y is 4y. 4 times negative 3 is negative 12. And then I told you for the denominators, you don't put them together. You just write them side by side. Don't waste your time foiling them, okay? Just write them side by side. You're going to have to try and stop yourself from foiling them because it's an addiction. You've been taught to distribute everything your whole lives. So you're going to try and distribute, but stop yourself. So we're going to get, oh, look at, I just got blue all over myself. I don't know how to stand by a board, guys. I haven't been by a board since March 13th. Good lucky, you know, good lucky. Good wording. Lucky Friday, the 13th, was our last day of classes. Did you know that? I haven't been at a board since then. I've been writing on a little tablet. I don't know how to hold markers. I have blue all over my hands. I don't know if you can see that. Okay, so we get 2y plus 5, and then y minus 3, minus, distribute a 1 through. 1 times 2y is 2y, and then 1 times 5 is 5. Remember I told you that minus sign just sits there. I don't deal with it till the next step. And then I get 2y plus 5, y minus 3. And I do not distribute those. Do not make yourselves lives harder. Do not make yourselves lives harder. Good English. Do not make your lives harder. Do not distribute those. If you distribute them, you'd have to factor them back out. Okay? So now we write them all over one denominator. 2y plus 5, y minus 3. In the top, I have 4y minus 12. I distribute the negative signs through. So negative 2y, so I get negative 2y. And then negative 5. Negative and positive 5 is negative 5. So it only changes signs to a positive if you minus a minus, right? Now I have common denominators, so I can write them all over one denominator. And collect like terms. Because I put all my numerators together. So I get 4y minus 2y is 2y. Minus 12 minus 5 is negative 17. And that's in brackets because they're attached to my minus sign. And after I collect like terms, the first thing I always ask myself after that is, can I take a GCF out of the top? 2y minus 17, there's nothing common, so I can't take out a GCF. So it's done. So I have to state NPVs though. My NPVs are going to be 2y plus 5 cannot equal 0. I'm writing off the board, no. And then y minus 3 cannot equal 0. 2y plus 5, I'm going to subtract 5 from both sides. So I get 2y cannot equal negative 5. Divide by 2. Y cannot equal negative 5 halves. And then here I'm going to add 3. Y cannot equal 3. And I follow behind with my semicolon. Y cannot equal negative 5 halves, comma 3, box it. One last example, the hardest one of them all. Obviously, save it for last, right? So G. For G, we get 2x plus 1 over x minus 5 minus x minus 4 over x plus 1. All right, I have a binomial denominator. They do not match. So I told you the very first step when you have a binomial denominator and they do not match is that you have to multiply them by each other. So I have x minus 5 on this side, x plus 1 on this side. I'm going to multiply this one by x plus 1. And I'm going to multiply this side by x minus 5. Now remember, you distribute the numerators, so we FOIL out the numerators, but we never distribute the denominators. Okay? We're never going to. So in the numerator, I'll just rewrite my denominator actually. So my denominator is going to be x minus 5, x plus 1. In the numerator, I'm going to get first times first. So I FOIL because I have a binomial times a binomial. 2 terms times 2 terms. So I'm going to get 2x times x, which is 2x squared. 2x times 1, which is 2x. 1 times x, which is x, or 1x. And then 1 times 1, which is a positive 1. And I have a minus sign, so I rewrite my minus sign. Right over my denominator, not FOILed together. But I do FOIL my numerator. So I go x times x, which is x squared. X times negative 5 is negative 5x, so outside times outside. Inside times inside. Negative 4 times x is negative 4x. And then last times last. Negative 4 times negative 5 is positive 20. Rewrite it over one denominator. X minus 5, x plus 1. So I'm going to get 2x squared plus 2x plus 1x plus 1. And now this is the catch. I have to remember to minus everything behind this. So minus a positive x squared, so I get minus x squared. Minus a negative 5x, so I get plus 5x. Minus a negative 4x, so I get plus 4x. And then minus a positive 20, so I get minus 20. Then I can collect like terms. So I get 2x squared minus x squared, which is x squared. 2x plus 1x is 3x, plus 5x is 8x, plus 4x is 12x. And then minus 1 minus 20 is minus 19, all in brackets, because they're all attached by plus or minus signs, so they're sewn together. And then I have x minus 5, x plus 1. And then I have statement of permissible values, or restrictions, NPVs. So I get x minus 5 cannot equal 0. X plus 1 cannot equal 0. So here I'm going to add 5. X cannot equal 5. And here I'm going to subtract 1. X cannot equal negative 1. So behind this, x cannot equal 5, comma negative 1, and box it. And that's simplifying by addition and subtraction. And I have to stop recording, which I'm not sure how to do.